Okay, so let's answer number 5 from 9.1, because this is also, this is a kind of an interesting problem. But so with number 5, we have f of x equals cosine of pi over 2x. And then we're also told that a sub n is f of 2n. Okay, cool. So then in part A, we're asked, does limit as x approaches infinity of f of x exist? And the answer is no. The answer to that question is definitely no. Because if you look at a graph of f of x, so we know that the graph of cosine x looks like this, right? Right, so that's what the graph of cosine x looks like. Cosine of pi over 2x would just look the same way, but compressed, right? So so it's gonna still do this kind of wavy thing, and I don't know why I started at 0, because it does the same thing in the other direction, but it's gonna look the same way. So so no, it alternates. It alternates between -1 and +1 and stuff, right? So no, the limit as x approaches infinity of f of x does not exist. Well, okay, that's going to be important. You'll see why as we answer the next couple parts. So part B asks us to evaluate A1, A2, A3, A4, and A5. Well, A1 is going to be f of 2 times 1, right? Which is f of 2, which is cosine of pi over 2 times 2. Or in other words, just cosine of pi, which you could punch into your calculator if you don't have it memorized, right? But cosine goes with your x values. At pi, you're over at -1. So this is -1. A2 would be f of 2 times 2. That would be f of 4, which is cosine of pi over 2 times 4. Now that's cosine of 2 pi. Cosine of 2 pi is +1. Okay, A3, f of 2 times 3. That's f of 6, which is cosine of pi over 2 times 6. That would be cosine of 3 pi. Okay, so I think I see where this is going, right? Cosine 3 pi is going to be -1 again. So I suspect that A4 is going to be cosine of 4 pi, which is going to be +1, and A5 is going to be cosine of 5 pi, which is going to be a -1. Okay, so really this is just an alternating series, -1, +1, -1, +1, -1, +1, etc. So then part C asks us, does A n converge? And the answer is no. No, because limit as n approaches infinity of A sub n does not exist, right? Since it's just alternating between -1 and +1, the limit doesn't exist. This was not as interesting as I thought it was going to be when I first started the problem, because you see what's interesting is that, and I think probably if you did number 6, because number 6 does a similar thing but with b sub n equals 2n plus 1, and I bet what you get, So let's just think about number 6 for a second. So for number 6, it asks us to evaluate. So for number 6, b sub n is equal to f of 2n plus 1. And so in part A, they ask us to evaluate b1, b2, b3, b4, b5. So let's do that, because I think that's probably a more interesting outcome. Okay, so b1 would be f of 2 times 1 plus 1, so that's f of 3, which is cosine of pi over 2 times 3, or in other words, cosine of 3 pi over 2. And cosine of 3 pi over 2 is 0, right? b2 is f of 5. So I'm going to skip some steps, but I think that's going to give us cosine of 5 pi over 2, which is also 0. Okay, so this is interesting, right? So b3 is going to be f of 7, which is going to be cosine of 7 pi over 2, which is 0. Okay, b4 is going to be 0. b5 is going to be 0. So now, when they ask, well, does b sub n converge? And the answer is yes, it converges to 0. And so the reason that that's interesting is because even though the original function diverges, you can still build a sequence by picking just some of the values on the function, like we did here, that converges. So anyway, so I think that that's kind of an interesting thing. But that's the way that number 5 works. That's the way that it was. I think that's what it's supposed to try to point out to you. But because you only do the odd problems, right? So you didn't do number 6, so you don't quite see that, I guess, with number 5. But that was sort of the purpose of the exercise. Anyway, I hope that helps.